Bismillahirrahmanirrahim and Assalamu alaikum, my dear students. I welcome you all to the lecture number 2 of Electric Circuit Analysis 1. This is the second lecture of our online instruction of phase 2. Today I am going to continue with the linearity property that we studied in lecture number 1 in my previous lecture. Today I am going to make you understand the property or this principle with another example from our book, in which we'll see an electric circuit. We'll see the response of an electric circuit by altering or by changing the input, that is what we call the cause, and then what we'll see the effect of this on the output. In the given scenario, the circuit is given here. We are given 1, 2, 3, 4, 5 resistor, an independent source which is represented by a circle, and a dependent source. Please recall that a dependent source is always represented by a diamond shape, since we have polarity represented in it. So this means this is a voltage source. The dependent voltage source is 3Vx. This means this Vx is some parameter inside the circuit. When we look at the circuit, we find that Vx is across the voltage across 2 ohms. So Vx is 2 times multiplied by, as by Ohm's law, by the current going through this loop, which is I1. So what we have to do is, by linearity principle, we have to form a relationship between the input and the output, and then we'll find the value of output at different values of the input. First we are asked to find it at Vs is equal to 12 volt, and then when the voltage, input voltage, is doubled, we should find the value of I0. So this is a simple 2-loop circuit, and what I would prefer here is to use mesh analysis. In the circuit, you say, I just told you that Vs, which is the input, and I0 is the output. Let us solve this circuit, and I would prefer to use mesh analysis over here. I have 2 loops, and by mesh analysis I can assign currents to each of the loop. Loop 1 is assigned I1 current, and loop 2 is assigned I2 current. Please recall that the current direction is always taken as conventionally clockwise direction. And now each of the loop, what we do is we apply the Kirchhoff voltage law, which we summarize as KVL, represented by KVL. And the statement of Kirchhoff voltage law is that the summation of voltage losses across a loop or a mesh is equal to the voltage gain across that particular loop. So we have 4 elements in the first loop, that is a 6 ohm resistor, then a 2 ohm resistor, then a 4 ohm resistor, which is being shared by loop 1 and loop 2 and voltage source. So, and I just told you that voltage Vx is equal to 2I1. So please look at the circuit again. I would like you to look at the circuit again, which was this. So a 6 ohm resistor, a 2 ohm resistor, a 4 ohm resistor, and a voltage source. This 4 ohm resistor is being shared between 2 loops, I2 for loop 1 and loop 2. Now since I'm taking loop 1, so I1 will be the direction that I'll be pursuing. So by applying Ohm's law, what we get is V4 ohm is equal to Ri. R is 4 ohm, but we have 2I, that is I indicates the current, I1 minus I2. So this is how we'll find the voltage across this loop. Now applying Ohm's law, V6 ohm, I put the values IR, R is 6 ohm, I1 is the current, 2I1, then as I told you, the voltage across 4 ohm would be represented by this, and Vs. Now what we do is we gather the similar terms. I1 is here, I1 is here, and I1 is here. So what I do is I gather all the I1 current values and leave the rest. By simplifying this equation, I get to know that this equation is equivalent to 12I1 minus 4I2 plus Vs. I cannot further simplify this equation, so I'll stop it here. Now, stop this equation here. Now what we'll do is, as by mesh analysis, I'll move on to the loop number 2, which is this loop. I have 5 elements in this loop: a dependent source, 3 resistor, and then an independent source. This resistor has 1 current flowing through it, that is I2. This resistor has the same current going through it. However, again, the same 4 ohm resistor have 2 current going through it, I2 minus I1. Now I'll go in the clockwise direction, and the voltage will be V4 ohm is equal to 4 I2 minus I1, and we'll apply the same Kirchhoff voltage law, that is sum of voltage drop is equal to the sum of voltage gain across a circuit. as I told you that the 4 ohm resistor value will be found in this way, and the 8 ohm is 8I2 simple. Then the other 4 ohm at the rightmost side, that is I'm talking about this resistor, this will, the voltage across this will be 4I2. Now the independent voltage source is 3Vx. We'll put the value of Vx. Please recall that I just told you that Vx is 2I1. I'll put the value, insert it in here, and what I get is 6I1. So now we'll come back to the voltage equation and apply the voltage KVL equation. And while we traverse the loop, please remember that when we go from low potential or minus sign to plus or high potential, it is a voltage gain across that element. However, whereas when we traverse the loop and we go from plus or high potential to low potential, it is always a voltage loss. So by applying loop equation to loop number 2, I get is these are the voltage gain terms, and on this side I have all these 3 elements that they encounter a voltage loss. So I insert the values Vx 2I1, then 4I2 minus I1, and I just told you how to find these values. By simplifying, what I do is I gather all the I2 terms. I2 is here, I2 is here, and I2 is here. When I sum up all these, I get 16I2. Now I'll rearrange the terms. I1 is here and I1 is here. What I will do is I take both these terms on the left side of the equality, and by rearranging, what I get is I gather the I1 terms. This becomes Vs plus 10I1 minus 16I2. Now I cannot further solve this equation, so what I will do is I'll try to do some arithmetic operation on equation loop equation 1 and loop equation 2. So recall, loop equation 1 was this, loop equation 2 is this. What I do is I subtract loop equation 2 current from equation 1, and I get is Vs cancels out. I1 is 12. Now the sign of this is changed because I'm subtracting it, so it's 12 minus 10 plus I2, and the sign of this is changed, 16 minus, because minus changes the sign of the term. I'll further simplify it. 12 minus 10 is 2I1, 16 minus 4 is 12I2 is equal to 0. This is how I'll get a relationship between I1 and I2. And now once I got this relationship, I1 is equal to 6 minus 6I2, I can insert this value, substitute this in any of the equation. I prefer to put the value of I1 in equation 1. I do this because I actually want a relationship between I2, which is I0, between Vs, which is the input. So by inserting the value of I1 minus 6I2, I get 12 into 6 is 72, and further by simplifying it, I get this value. Taking Vs to the other side of the equality, I do is minus minus. I told you I2 is equal to I0, which is actually the unknown or the output current. Now what I get is I2 is equal to 1 over 76 into Vs, or you can say Vs by 76. This is the scaling factor that I required, because now this shows the relationship of Vs, it is the input or the cost, to the output. Output is I2, I0, and this is what I require. In linearity principle property, we have to establish this relationship. We need to find this relationship. Once I'm done with finding this relationship, you can just simply insert the values of different Vs that is given to you. The Vs is equal to 12 volt. I insert the value and I get the output or the current value as 0.616 ampere. Now for the next time, I was given the value of Vs double this, that is 24 volt, and I found that when I double Vs, I get I0 is equal to 0.32 ampere. So this is how you find the, first of all you find the scaling factor using linearity principle, and then you can find the output, unknown output for different values of input. If you have any problems, we'll discuss it in our online session with respect to this lecture. Thank you. Best of luck. Allah Hafiz.